now let's talk about the energy recovery from our trash. Incineration or burning produces energy from trash. So most cities use waste incinerators to burn their municipal waste. And this is because they're faced with growing piles of garbage and lack of available landfills at any price, meaning they have to do something with their trash. We're running out of landfill space, so they're tending to burn it. Instead of just burning and forgetting about it, most incinerators couple this burning to some degree of energy recovery. In other words, they're using the heat that's derived from incinerating the trash to heat nearby buildings or to produce steam and generate electricity. The refuse-derived fuel is what's left after the unburnable or recyclable materials are removed. There's another approach called a mass burn. This is when everything is dumped into a giant furnace, and then it's not sorted, it's just all dumped in there. And the idea is just to burn as much as possible. So this technique avoids the expensive and unpleasant job of sorting the different trash materials, but it produces more unburned ash, and often it produces more air pollution because it's burning batteries, it's burning plastic and other mixed substances at the same time. So as you can imagine, these incinerators have the potential to produce a whole host of health risks. They have to be well managed and well built in order to be as safe as possible for nearby fence line communities. If they're not, these incinerators can produce large amounts of ash and hazardous airborne emissions, greatly damaging the health and development of those fence line communities in the surrounding area. The residues from those mass burning practices often contain a variety of toxic components. We're talking about things like dioxins and furans, and even heavy metals like lead and cadmium. All of that can be found in the incinerator ash. These metals, they tend to concentrate in the ash. And what's really bad about that is that when you breathe in that ash, it has the potential to deeply embed in the lungs, posing health risks far into the future. There was one EPA study that looked at a whole host of incinerators across the United States. And what they found is that all of the incinerators that they examined exceeded cadmium standards. Again, that is a heavy metal toxin. And about 80% of the incinerators they examined exceeded lead standards. So all of this just to show that incinerators, even though we're using them widely across the US, they pose a huge health risk to neighboring fence line communities. So the question is, how do we shrink our waste stream? Compared to landfilling and incineration, recycling saves money, energy, raw materials, land space, and has a potential to reduce pollution. Recycling is defined as the reprocessing of discarded materials into new products. Sometimes the same products are remade. So for instance, old aluminum cans and glass bottles that were used to house beverages are usually melted and recast into new cans and new bottles for new beverages. That is actually considered true recycling. Alternatively, you can make entirely new products out of that recycled material. For instance, old tires can be shredded and turned into rubberized playground or road surfacing. So this is actually not recycling, sensu stricto. This is repurposing, but still it is using old materials to create something new, and thereby it is allowing the reduction of pollution, the easing up of land space because it's not going into a landfill, and the decreased reliance on new raw materials. So despite recycling being our best avenue for reducing the amount of pollution and landfill use, it continues to face challenges. The problem is making recycling pay for itself is the critical challenges, because some materials are heavy and are of low value, so they can be difficult to ship economically to those recycling facilities. There have been some dramatic successes in recycling in recent years. Most notably, the US recycles or composts 1/3 of all municipal solid waste. So that's great. Recycling is on almost everybody's radar, but unfortunately, we still haven't made it entirely economical. Aluminum is probably the easiest and most valuable material to recycle, and yet despite this, only half of aluminum cans are recycled in the United States. The tendency to throw away all of this aluminum amounts to about 350,000 metric tons. That is enough to make nearly 4,000 Boeing 747 airplanes, which is just wild. So this is especially unfortunate because producing new aluminum is extraordinarily energy intensive, while recycling that aluminum is extremely easy. Recycling also faces the pitfall of wild fluctuations in commodity prices. And so an example of this is newsprint. So newsprint in the year 1995 cost about $160 a ton. By 1999, it dropped to just $42 per ton. And then fast forward to 2009, it climbed to $650 a ton. So those places that are recycling newsprint, they can't count on a consistent market value of that recycled newspaper, which makes predicting how much they want, how much they can take from those sorting facilities extremely difficult. So here we have the different waste disposal methods across different countries. It's showing the percentage that is relied on landfills, incineration, and then recycling or composting. We have data for Germany, Sweden, Denmark, France, the United Kingdom, and the United States. So starting with Germany, we see that nearly 40% of its refuse or garbage is incinerated, while about 60% is recycled or composted. They do not heavily rely on landfills in Germany. We can contrast that with what we do here in the United States, where over 50% of our trash ends up in landfills. A small percentage, about 10% here, is incinerated, and then about a quarter is recycled or composted. So there's a big gap between practices in the United States and practices in Germany, for example. We can take a look at US recycling rates with the percent recycled here, and then the different items outlined with different bars. We see that topping the chart here is auto batteries. And this is because recycling car batteries in the United States is required by law in order to keep lead out of the waste stream. So just behind that, at just over 60%, we have steel cans and yard trimmings that are being recycled. Just about 50% of all paper and paperboard is recycled. Underneath that, just over 40% of aluminum beer and soft drink cans are recycled. Below that, we have tires, and then milk and water bottles that are plastic. Unfortunately, we do a very poor job of recycling our plastic soft drink bottles. Only about a quarter of those tend to be recycled. And then finally, just over 20% of our glass containers are recycled in the United States. We know that energy, space, and money are all saved when we begin to recycle. Curbside pickup of recycling costs about $35 per ton. We can compare that $35 per ton for recycling purposes to how much it costs per ton to just dispose of that material. And it actually costs way more, about $80 per ton, to just dispose of that garbage in a landfill. So it's actually much cheaper to recycle those recyclables than it is to just throw them away. In addition, we know that recycling lowers demand for raw resources. The United States cuts down about 2 million trees every day to produce newsprint and paper products. As you can imagine, that's a huge, heavy drain on our forests. Recycling the print run of a single Sunday issue of the New York Times would spare about 75,000 trees. In addition to saving our trees, we can also shift our eyes to petroleum products. Every piece of plastic made in the United States reduces the reserve supply of petroleum and makes the country more dependent on foreign oil. So not only are we saving money and space by recycling our plastic products, we're also reducing the amount of reliance that we have as a country on foreign petroleum resources. We know that recycling also reduces energy consumption and air pollution. And the two things that fold into this are making new steel and then making new aluminum. So making new steel from old scrap offers up to 75% in energy savings, which is a whole lot. But then you consider the energy savings in terms of producing aluminum, and we can save energy by about 95% if we produce aluminum from scrap aluminum instead of new bauxite ore. And so despite the cut of energy use by about 95% by just using scrap aluminum, the United States still throws away more than 1 million tons of aluminum every year. So what makes something recyclable? I pulled this off of the EPA website, and it's all about waste management. So number one, it has to be able to be collected. Convenient recycling collection is important for successful programs. If you're asking the customer or the household to drive miles and miles away in order to recycle, they're less likely to recycle it. At the same time, single stream recyclables are often wet, dirty, and contain broken glass. The material is flattened during compaction, and the flattened recyclables may be missorted. So it's extremely important that when you place your recycling items in the bin, that you clean the item beforehand. Number two, it needs to be processed. So processing includes sorting those single stream recyclables, and that requires both technology and labor. So people physically sorting that recyclable material. There are, of course, physical limitations to what can be recycled. Equipment and staff may not be able to identify or separate certain materials. So some things might be lost in the shuffle. Film plastic is the single biggest problem at these material recycling facilities, and we'll talk about that on the next slide. And then finally, marketing. Robust markets are critical for sustainable recycling. And it all comes down to this equation of volume plus value equals market. The market is global. You'll learn about this in the Plastic China trailer, as well as the 99% Invisible podcast that I'm going to assign to you. But these markets are global, and we export the majority of our recyclable materials. There is a robust market for clean and dry film plastic that is collected in take-back programs, but none for film collected at curbside. So what are we talking about when we're talking about plastic film? You might be most familiar with film plastic in the way of those grocery bags that you get at Kroger or Walmart. Please do not ever recycle these. Don't throw these in your curbside bin. They get in the way of the machinery process. They seize up the gears. They get wrapped tightly around the mechanisms that sort the trash. And then so the whole mechanism has to be shut down while workers go and cut off these bags that get wrapped and coiled around. So please, if you have those trash, or if you have those bags from your grocery run, instead of throwing them in your curbside pickup or taking them to the recycling center, bundle them up and take them back to the grocery store. The grocery store has avenues that they have for recycling. They don't get sorted in these mass recycling facilities. Instead, they get sorted somewhere else. So do not recycle your plastic bags. Next, we're going to watch a video about this sorting process.
Material recovery facilities, or MRFs, are where recyclables go after they leave the curbside bins. The MRF sorts, processes, and bales these recyclables to be shipped to manufacturers. First, all the materials are unloaded and placed onto a conveyor belt in preparation for sorting. They then fall onto an inclined screen and are sorted by gravity and shape. The paper products travel up the screen. While the paper products travel up, containers fall back and through the screen onto a new conveyor that takes them to their next step in the sorting process. This process isn't foolproof. Workers sort out trash and misdirected recyclables by hand. This lessens the amount of contamination in the final recycling load. The paper products are dropped into a holding container that waits at the end of the conveyor, then baled. Plastic bags are the number one problem at a MRF. While they are recyclable, a MRF can't process them. Take plastic bags to a grocery store, and they will take care of recycling those. The containers that previously rolled down and through the screen begin the next step with super strong magnets that attract steel. They pick steel products up and move them to another conveyor that delivers them to their appropriate holding container. Magnets don't attract aluminum, so it's sorted through a kind of reverse magnet called an eddy current, which shoots the aluminum products into a catch bin. Next, the heavier glass falls into a pit, while the lighter plastic materials float onto the next conveyor belt for further sorting. The now broken glass, called cullet, is then shipped to a glass recycling facility. Sometimes plastics are manually sorted, but more and more this is done through optical sorting. This means the plastic is scanned and sorted by puffs of air into groups of type and color. Number one plastics are taken out of the process, stored, and baled. Plastics the scanners don't pick up are further sorted by workers into specific groups. Plastics not removed during this process fall off the end of the conveyor into a pit to be shipped to plastic manufacturers. After all the materials have been sorted and processed, except for the glass, they are baled and can weigh anywhere from 1,000 to 1,500 pounds. Manufacturers buy these bales and create new products of that recycled material. Find out more at recyclemorenc.org.
Okay, so all this has to do with volume and price, and the marketability comes from those two parameters. So things that you don't get a whole lot of and they're really costly, you're not going to be able to effectively recycle that. The material recycling facility is not going to want to spend the time and effort in devoting resources to that product. However, if you have something that is going to yield you a lot of returns in terms of pricing, and you can produce it at a large quantity, perhaps like flattened cardboard, then the recycling facility is in fact going to have a large interest in recycling that material. The biggest problem right now is contamination. The contamination loads of recycled materials is on average 16% of inbound tons, and it is increasing. So we can see here in this chart going from September 2011 through June 2013-ish, that the inbound tons of recycled materials has been increasing. Those are the green bars. But the amount of residue or food waste or gunk that's left inside of the plastic or other recycled material is also increasing. So contamination can be up to 50% of incoming loads, and contamination costs an average of $140 per ton. So especially in America, we're doing a better and better job of recycling our materials, but the problem is we are not effectively cleaning those materials before we put them in the recycling bin. And so they are pretty unusable. So markets are demanding reduced contamination. They're actually across the globe refusing our recyclable materials because it is too contaminated. And those processing costs have increased by about 20% in 2 years, which is driving up the cost to customers who are sending out that recyclable material. So this problem is laid out in this 99% Invisible podcast episode called National Sword, and is all about our export of recycling to China and how there's now basically a crisis in that China is refusing to accept our recycling materials. So I would love for you to listen to this 45-minute podcast, and then in your unit for reflection, provide a 2-paragraph of reflection on this podcast episode. Also, watch the Plastic China movie trailer that is discussed in this podcast. Tell me what surprised you, if you knew about this problem already, if perhaps you now will take up the practice of cleaning your recyclable materials after listening to this podcast. Just a 2-paragraph reflection in your unit for reflection. So what do these changes mean for recycling? The changing waste stream has increased production costs, driving up the overall cost of recycling. There are more non-recyclable materials in the feedstock, and this increases the cost of recycling programs. You may have noticed that in your area, they're no longer accepting glass recyclables, for example. They stopped collecting glass in my neighborhood, and that's because it is simply not cost efficient anymore for them to accept glass and export that glass. So there are more low value materials in the recycling stream right now, which reduces the overall revenue. Communities with revenue sharing may see less revenue from the sales of those recycling commodities. A lighter recycling stream makes it harder to increase recycling rates. That's because more lightweight plastic means more lower value materials. So what can you do? What are these recycling rules that we can all follow? Number 1, recycle all bottles, cans, and paper. Importantly, keep these items clean and dry. And then finally, most important, no plastic bags from the grocery store. Okay, so you can recycle plastic bottles and containers. Make sure to rinse them under the sink. You can even put them in your dishwasher sometimes. Just make sure that they are both clean and dry before you recycle them. You can recycle paper. Importantly, don't try to recycle your cardboard that is your pizza cardboard from your pizza delivery. It is contaminated, it is dirty, it is greasy, it is no longer usable, unfortunately. Also, your food, beverage, and cans, your cartons, make sure those are cleaned as well. And participation is key. Make sure you're following the rules: no plastic film bags, no foam cups and containers, no food waste, and no needles.